Hello students, welcome to the classes. In this session, we will see few MCQs on the chapter solid state. Okay, so look at the first question. Which of the following will show anisotropic nature? See, there are basically two types of solids, crystalline solids and amorphous solids. Right, so amorphous solids are not, the properties of amorphous solids are not directional oriented. It means they are not dependent on direction. It means what? In whatever direction you measure the properties, they remain the same. It means amorphous solids show isotropic nature. The crystalline solids, okay, they depend on the direction. It means what? Their properties are different along different directions. This means for crystalline solids, the properties are directional oriented. It means they are anisotropic. Anisotropic means the properties of crystalline solids differ. The properties of crystalline solids differ in different directions. So here anisotropic we need to check. It means we need to check for crystalline solids. So out of these four, which of them is crystalline solids? The barium chloride is a crystalline solid. Okay, so the option is what? Option B, barium chloride. Now let's see the second question. Which of the following is most asymmetrical structure? So to see this problem, I'll just we'll see a table now. Okay, so here you can see we have cube, right, and we have hexagon. See here we have cube, hexagonal, triclinic, orthorhombic. Cubic, here you can see the parameters, and hexagonal, yes, here you can see the parameters, and triclinic you can see the parameters, and we have orthorhombic, you can see the parameters here. So these are axial lengths, the edge lengths, and these are the angles. Okay, so out of these things, look which of them are most asymmetrical. Most asymmetrical means, so the edges should not be equal and angles should not be equal to each other. See, here you can see all three edges are equal, all angles are equal. This is most symmetrical. This is most symmetrical. Okay, this is most symmetrical. Now here you see one more is orthorhombic diagonal. Yes, right. Here you can see angles are what? Symmetrical. Angles are equal. Now here you see at least two sides and two angles are equal. But in case of triclinic, you can see none of the edges are equal and none of the angles are equal. This means what? The triclinic is the most asymmetrical structure. So which option? Option C, triclinic, which is the most asymmetrical structure. Right. Now let's see the third one. The coordination number of cation occupying a tetrahedral void and octahedral void respectively are. Coordination numbers they have asked. See how a tetrahedral void is formed. See here, let me consider a triangular void. Okay, see here, this is a triangular void. I'll just do one thing. Yes, yeah, this is a triangular void. On the triangular void, when one more atom comes and occupy, okay, now we get a tetrahedral void here. Okay, now how an octahedral void is formed? Let's see. On the void, if one more void sits, or on the void if one more void is placed, we get what? Octahedral void. So in tetrahedral void, a particle is nearer to how many particles? You can see 1, 2, 3, 4. So it means the coordination number for tetrahedral void is what? 4. For octahedral void, okay, a particle is nearer to how many particles? You can see 1, 2, 3. 3 red and 3 blues. It means it is nearer to 6 particles. For tetrahedral void, to form tetrahedral void, okay, or in case of tetrahedral void, okay, a particle is nearer to 4 other particles. So what is actually coordination number? Coordination number is the number of neighboring particles or the number of nearest particles. In case of tetrahedral void, 4 particles are nearer to it for any given particle. In case of octahedral void, 6 particles are nearer to it. It means for tetrahedral void, coordination number is 4. For octahedral, it is 6. So which option? 4, 6 is your answer. Right. Now let's see the next question. How many lattice points are present in the unit cell of NaCl? Okay, how a unit cell of NaCl is made up of? Okay, NaCl, in case of NaCl, the corners are occupied by Na. Okay, you can see the corners are occupied by Na, also the faces are occupied by the Na, and Cl is occupying the edges. Cl is occupying the edges. It means in this unit cell, 8 corners, right, plus 6 faces, total how much? 14. So there are 14 Na atoms, or Na ions. Now Cls are occupying the edges. Cls are occupying edges. There are 12 edges, and also one Cl is occupying or it is present inside the what? Inside the body. So that is one more. So how much you get? Total 13. So 14 plus 13, total we have what? 27 lattice points are present in what? The NaCl structure. Okay. So let's see the next question then. A substance AXBY crystallizes in face-centered cubic lattice in which atom A occupies each corner of the cube and atom B occupy the centers of each face of the cube. Identify the correct composition of the substance AXBY. Right. Now see here what they are given. Atoms A occupy corner. There are 8 corners in cube. And what is the contribution of corner atom? Contribution of corner atom is 1 by 8. So it means the effective number of particles A in unit cell is nothing but 1. So how we have calculated? In the cube there are 8 corners and contribution of corner atom is what? 1 by 8. 8 into 1 by 8 is what? 1. Now the B atoms will occupy the center of each face. You can see there are 6 faces and contribution of face particle is what? 1 by 2. So 2 ones are 2 threes are, it means it is 3. So they are in the ratio 1:3. So A is 1 and B is 3, right. So what's the formula then? AB3. So which option? Option A, AB3. Now let's see the 6th question. So they have asked ionic radii of Rb plus is and I minus are 1.46 pm and 2.16 pm picometer. Okay. Now what they have asked is what's the coordination number? To find coordination number, we need to find radius ratio. Radius ratio is given by R plus by R minus. R plus is radius of cation, it's 1.46, right, divided by radius of anion is what? 2.16. So I will write this as 14 by 21, 7 2s are, 7 3s are, 2 by 3 is approximately 0.66. Okay. Now if I look at this table now, okay, here you can see if the radius ratio, see here they are given, the first column represents radius ratio, okay, here you can see the radius ratio. Okay, so now here we have got radius ratio as 0.66. It lies in this value, right, 0.414 to 0.732. It lies between these two, right. So it means the coordination number for such compound is what? 6. So which option? Option 6. You need to remember this table. You just need to calculate the radius ratio and check in which region it lies, right. Yeah, next we'll see the next question. Yes. Now which substance will conduct electricity in solid state, right. See here, which of them will conduct the electricity in solid state? Obviously graphite. Why? we know graphite is a good conductor of electricity, right? So it's a allotrope of carbon. Even though carbon is a non-metal, graphite is a good conductor of electricity. Yeah, I agree, NaCl will conduct electricity, but only in molten or aqueous, or I can say, yeah, or in solution state. Only in molten or solution state it will conduct. It will not conduct in solid state. Okay, it will conduct only in molten or solution state. So the graphite will conduct what? The electricity or the current in what? Solid state. Diamond and iodine are the poor conductors, or I can say the insulators, right, in solid state. The next question, molten sodium chloride conduct electricity due to the presence of, see, molten NaCl is being splitted into Na plus and Cl minus in the molten state. It means there are free ions. Now these ions will move and they help in conduction of what? Electricity. So it means the current here is due to because of free ions. In case of molten sodium chloride, current is due to what? Because of free ions, right? Now let's see the next question. In covalent solids, the units which occupy the lattice points are, see, what are covalent solids? The solids which are formed or which are grouped together by what? Covalent bonds. Okay, covalent bonds are formed between what? Covalent bonds are not formed between electrons, they are not formed between ions. The covalent bonds are formed between atoms. Okay, so it means in covalent solids, the units which occupy the lattice points are nothing but what? Atoms. Let's see the 10th one. Potassium crystallizes in BCC lattice. Hence, the coordination number of potassium in potassium metal is. They have asked what? Coordination number. Now they are given BCC lattice. Now look into this table. Here they are given space lattice and coordination number. So you can see here, if the space lattice is simple cubic, coordination number is 6. Okay. Now this is not your case because they are given BCC lattice. So for BCC lattice, what is the coordination number? 8. If it is simple cubic, it is 6. If it is face centered cubic, it is 12. Now here they are given BCC structure, body centered cubic, right? So it means the coordination number is 8. So which option? Option D, 8. Okay. Now these are the 10 MCQs based on solid state. We will continue with the MCQs in the next part based on what? The solid state chapter.